Welcome everyone in lecture number 43 of statistics. In this video lecture, we will learn how to test the independence of two attributes. Let us consider two attributes A and B. A is divided into R classes and B is divided into S classes. Here, attribute means characteristic of people or an object. Like you can say, you can take A as IQ level that has different categories like average, below average, poor, very intelligent, intelligent, and you can take some another attribute like color of hair, gray, white, brown, black, right? So here we are taking two attributes and we want to test that whether these two attributes are independent or dependent on each other. Such a classification in which attributes are divided into more than two classes is known as manifold classification. Means if you can divide a characteristic into more than one categories, subcategories, then this type of categorization is called manifold classification. Here we construct R cross S contingency table. Here A1, A2, AI, AR are the number of persons. Sorry, it is the category of attribute A, and here is the category of attribute B. A1, B1 denoting the number of persons having these two characteristics, A1 and B1, and here B1, B2, BJ, BS is denoting the row total, and A1, A2, AI, AR denotes here the column total. So AI is number of person possessing the attribute AI, means ये AI जो number आपको देगा ये total, this number denotes the number of people having the characteristic or attribute A1. This A2 indicates the number of people having the characteristic A2, and this particular entry A2B1 shows the number of people possessing the attribute A2 and B1 only. Capital N denotes the total number of people in this table. So this type of table that gives the idea about the number of people having different combinations of two characteristics is called R cross S contingency table. Summation AI, that is summation of these AIs, is capital N, which is equal to summation of these BJs. So this is total number of person in the population. We want to test if two attributes A and B under consideration are independent or not. So we set the null hypothesis as that attributes are independent of each other. Null hypothesis says no difference. There is no dependency. Two attributes are independent of each other. So under this null hypothesis, we calculate the following cell frequencies. Probability of AI means probability that a person possess the attribute AI. कितने people A1 attribute possess करते हैं इस टेबल में? ये सारे, ये कितने हैं? A1. तो what is the probability that person possess the attribute A1? Is A1 upon capital N. Similarly, Probability that a person possesses the attribute AI is given by AI divided by N. I could be 1, 2, up to R. Similarly, probability of Bj means probability that a person possesses the attribute Bj, means what is the probability that people possess the attribute B1. Sum of all these, that sum is given by B1. So it is B1 upon N. So probability that a person possesses the attribute Bj is given by Bj divided by N. And probability AI Bj means probability that a person possesses both attributes AI and Bj. This is equal to probability of AI into probability of Bj, because these two attributes are independent of each other. We have assumed in this null hypothesis. So we are doing this calculation under the null hypothesis. So expected value of number of person possessing the attribute AI and Bj is probability multiplied by total number of people. That gives us the number of people, and that is given by AI Bj divided by N. So expected number of person possessing the attribute AI and Bj is given by AI Bj divided by N. That is equal to AI. What is AI? AI is the column total AI, and Bj is row total. Okay. So here we have written row total into column total divided by N. So for any particular entry here, its expected frequency is given by the row total of that entry into column total divided by N. So that gives us the expected frequency of that pair. So chi-square statistics for independence of attributes is summation Fo minus Fe whole square divided by Fe, where Fo is observed frequency, Fe means expected frequency, and observed means जो हमें क्वेश्चन में गिवन होंगी observed. Observed का मतलब these are noted through experiment or through observations. And expected means you have calculated them theoretically by using a formula or by using mathematical concepts. So this is expected frequency divided by expected frequency. We do this for each and every entry and then add them all to get the value of chi-square. We will do one example to understand this. Next, we understand what is the degree of freedom, because we need degree of freedom to find the tabulated value of chi-square. So degree of freedom is defined as number of independent variates which are used in the calculation of chi-square. Suppose this is a R cross S contingency table. Here we have 3 rows and 4 columns, and this row total is given to us and column total is also given to us. So if these ticks in green shows that these entries are known. So if you know these entries, you can find this entry using this row total by subtracting these three entries sum from this. You can get this value. Similarly, if we know all these three values, then we can calculate this value using this row total number 2. And because column total is known, so and these two values are also known, we can find this value also. We can find this value, and this value. So this value, this, these are dependent values on these entries. And these numbers, these values which are shown in green, these are independent. So total number of values are 6, which is total number of rows minus 1 into total number of columns minus 1, product of these two. So degree of freedom in case of chi-square test for independency of two attributes is row minus 1 into column minus 1. We take the following conditions before applying chi-square test: that sample observations should be independent, constraints on cell frequencies should be linear, no theoretical cell frequency, that is Fe, should be less than 5. जो आप Fe कैलकुलेट करते हो उसकी वैल्यू 5 से कम नहीं आनी चाहिए. कैपिटल N की वैल्यू 50 या उससे ज्यादा होनी चाहिए. So we take care of these 2 points while doing numerical problems. The problem is, from the following table, test the hypothesis that flower color is independent of flatness of leaf. This is the flower color and this is the leaf flatness, flat leaves, curled leaves. White flower have flat leaves. The flowers which are white and the leaves are flat, they were 99. The flowers which are white and their leaves are curled are found to be 36. Red flowers which have flat leaves are 20 and which have curled leaves are 5. So this row total is 135 and it is 25. We have to calculate, we have to find out whether the color of flower is independent of flatness of leaf or not. So we take the null hypothesis that these two are independent of each other. Under this null hypothesis, we calculate the expected frequencies. So expected frequency of means this the expected value at this point is row total, which is 135, and column total is 119 divided by total number of uh, flowers, total number of entries here in this table, which is 160. For this, the expected value is 135 because row total is 135 and column total is 41 divided by 160. Similarly, for 20, expected value is 25 into 11 divided by 160. And for 5, it is 25 into column total, which is 41 into 1 divided by 160. So we have these as expected frequencies. These are observed frequencies and these are theoretically found frequencies. So now we apply the formula of chi-square, which is Fo minus Fe whole square divided by Fe. See here, this is Fo, this is Fo, this is Fe, 99 minus 100.41 whole square divided by 100.41. Similarly, we do this for each and every entry and solve it. We get 0.494. Then we find degree of freedom, which is row minus 1 into column minus 1. So you can see that total number of rows are 2 and total number of columns are also 2. So degree of freedom is 2 minus 1 into 2 minus 1, that is 1. And we always apply the right tail test in this testing of hypothesis about two attributes. So right tail area we are testing it as at 5% level of significance. So this area is 5%. Find the chi-square value using 5% and 1 degree of freedom, that is 3.841. And you can see that this 0.494, which is calculated value, is less than tabulated value of chi-square. So null hypothesis is accepted. Means we can say that flower color is independent of flatness of leaf. So this is called the test of hypothesis about independence of attributes. More problems on this test we'll do in my next class. Thank you very much.